Yep, so that's working. Making sure I'm recording from the right channel. It is. So we are good to go. All right. So what we'll do today, let me go back to Moodle first. I have some leftover stuff from yesterday, but that's okay. We'll go ahead and switch to the proper stuff for today. All right. This is cisp310. And we'll go ahead. I asked the department head, Damon Antos, and he said, well, we probably can add everybody, So if you're on wait list, I'm going to give you a permission number, and we'll all be good. Okay, the only thing I need you guys to do if you're on wait list is to sign in to Moodle and use ASM lowercase as the enrollment key, because I'm going to use that to identify who is on waitlist and then send you guys the permission number to add to the class. Is that okay? So if you're on waitlist but you're not, in Moodle, go, sign into Moodle and get into this class in Moodle. Yep.
You said you're going to send it to us in Moodle?
I will send you a message in Moodle, but it will arrive at your apps.lostreals.edu account.
Okay.
And if you have it forwarded, over there, then you'll get it to whatever email address it forwards
this
to.
afternoon, or?
Probably sometime today. My home internet connection has been broken for 3 days.
Okay.
So I suppose I could, just tether my phone and use that, but I'm still in the middle of the cycle, so I don't want to use up all my bandwidth just yet. So. Yeah, well, Pokemon Go doesn't use up that much, bandwidth, so that's okay. Besides, I'm doing it on campus, so I'm just using the Wi-Fi. Exactly. Well, there's no reason why I should do it somewhere else, because on campus they have tons of stops, gyms, and Pokemon. So, I can sit in my office and just click every 5 minutes, right? All right. So first thing first, I do have the homework assignment for you guys. It's the lab, quote unquote, lab activity, setting up a Linux environment for homework assignments. Okay. So you just have to really just follow these instructions and get it done. Okay. So I'm going to read the instructions. If you have any questions about the instruction itself, let me know so I can clarify the terms or whatever you need to ask. So the first thing you need to do is to click here, okay, or right click and then save, the file. You are going to download a single zip file. If you haven't done this on Tuesday, it's just a zip file. It's really big, about 1 point something gigabytes, but it's just one single zip file. Download that file. Okay, are you guys ready? Okay, so it's just one single zip file, about 1 point something gigabytes. I cannot remember exactly how big it was, but it's 1 point something gigabytes. Download it, and then you want to unzip it into a particular folder that you have access to. Now, my recommendation is to get an external hard drive, external SSD, or something that's relatively fast with about 4 to 8 gigs left on it. And then you want to unzip this zip file as a single folder onto that drive. Okay, now once you have that, you can take that thumb drive or external hard drive with you, plug it into any Windows machine, and start up the virtual machine that you need to get homework assignments done. There's nothing to install. You don't even need administrative right to get this thing working. Is that okay? Yep.
The only thing I would say about putting it on a flash drive is that it runs like CRAP from a flash drive.
Oh, okay.
My suggestion would be you can install it to a flash drive, but when you run it, have the operating system file itself queue whatever file it is. Move that to your hard drive and change the start file.
Yeah, but then you have to remember to move it back on if you want to save the changes.
Is there a problem if we have it on our main drive?
Sorry?
Is there a problem if it's on our main drive?
Nope, not a problem at all. Okay, if you have your laptop computer, you can just unzip it into your internal hard drive or SSD. Not a problem. The idea of using a USB thumb drive is for people who do not bring a laptop computer to school. So this way, you can just plug in the USB thumb drive in the lab or at home. It will be the same virtual machine. Okay. All right. So according to this, which may or may not be 100% correct because I have changed the distribution a little bit over time. So if the file itself is 1.4 gigabytes and it will decompress to 3.5 gigabytes. However, as you use the virtual machine image file will increase over time. So you don't want to have just enough space to store everything. You want to give it at least about 1 gigabyte of spare space, just so that you won't run out of space in the semester. Okay. Once you have unzipped the file, you can delete the zip file itself, which is about 1.4 gigabytes. So after you unzip the file, everything will be contained in a folder called Linux, just lowercase Linux. There are two batch files. One is start32.bat, the other one is start64.bat. Now the extension .bat may or may not display depending on how you configure Windows. Because by default, I think Windows does not display known extensions. So you might just see start32 and start64. But that's okay. These names are fairly unique. There's only one file with that name. So even without the extension, you should be able to tell which one you're using. The virtual machine, according to the script, the batch file, is going to set up to use 512 megabytes of RAM. It does not really need that much. So if you want to tweak it because you don't have that much RAM on an older machine or a lesser configured machine, you can lower that easily to 256 and it will still run fine. Okay, so let's move on. The emulator used in this distribution is QEMU. It is open source, but it's not fast because it cannot get to the kernel accelerator module. Even if your processor has acceleration for virtualization, it's not going to be able to utilize it. Which basically, the bottom line is, it's going to be slow to start up. Okay. Once it starts, on the other hand, I really doubt that you guys can out-type the virtual machine. And I personally cannot think fast enough to type that fast to begin with. So you just have to give it a few minutes, maybe 2 or 3 minutes to start up. Just start it up, walk away, do something else, come back, and then it will just work fine. Okay, it's just a little bit slow to start. So using QEMU, first, if you click the emulator, it will grab the mouse pointer. Don't panic if you cannot find the mouse pointer. On the title bar, it will tell you how to release the mouse grab. Okay, I think it's Control-Alt-G. Okay, they have changed that over time because it used to be just Control-Alt, but now they want Control-Alt-G to release the mouse. But just be aware. Okay, if you click inside the emulator console, it will grab your mouse. Let's see. Oh, when it's time to close the emulator, you can just close it like a normal app, by clicking the X, at the upper right corner of your application. It's not a good practice because it really is the same thing as just yanking the power cord out of a computer, except in this case it's in a virtual sense. The file system that I use on this virtual machine is fairly resistant to this sort of thing. Okay. It's just not a very safe way to do it, so I would just kind of do it the safe way, which is described later on in the same slide. Oops. There are two programs. They're basically tools. One is Winscp, which is a copying program, so that you can copy files between the virtual machine and the host environment. Okay. Now, obviously, these will only work in Windows. If you have a Mac, you don't even need these anymore, okay? Because on a Mac, SCP all lowercase is a command line command, so you can just transfer files between the host and the virtual machine without using Winscp. Putty, P-U-T-T-Y, is the other program that is included. This is an older version. If you feel that you want to download the latest and greatest version with better security features and whatnot, just go ahead and locate Putty and download it, put it into the same folder. This one does work, okay? It's just a little bit older. That's basically an SSH client for interaction. If you're using a Mac or a Linux distribution, SSH itself as a command will do the same thing. So if you're using a Mac or a Linux box as a host environment, you don't even need these two commands. These are only for Windows machines. All right. So obviously, both of these programs won't do anything until you have the virtual machine up and running, because their job is to act as clients to communicate with the server, and the virtual machine itself is a server in this context. So the rest of this is just describing, how to move files, into the virtual machine, because you are going to download this file. Just right-click and either save link as or save file as, and so on and so forth. Depends on your browser. It's just called different things. So you save the file, but you need to transfer this file onto the virtual machine. So this is why you need to use Winscp or just SCP depending on your environment. So the one thing you have to remember here is when you are connecting, either using PuTTY or Winscp, when they ask you for the IP address or the host name, it is localhost, because your virtual machine is running on the same platform or the same machine as your host environment. So that's why it's called localhost. The port number is automatically set to 22 because that's the default port for SSH. But since I cannot override a lower number port in a virtual machine, so I have to use 2200 as a port forwarding port. So that's why you have to change that port to 2200 and not just 22. All right? So are there any questions at this point? No questions? Okay, let's move on. There are 2 accounts already set up. The first one is a user account. The username of the user account is user, U-S-E-R, all lowercase. And the same thing for the password. So the password is user as well, just all lowercase. All right. So are there any questions about everything that I have described at this point? No questions? All right. So the next thing you want to do is to do it inside the virtual machine. So inside the virtual machine, you want to decompress the file that you download in the host environment, and you copy onto the virtual machine. And the first thing you want to do is to do an ls in the home directory, just to make sure that file is there to begin with. And then what you want to do is to run this command to decompress what we call a tarball. Okay, it's kind of the same thing as a zip file. It is compressed. It contains multiple files in a folder. But in Linux land or Unix land, we call these quote unquote tarballs. Tar, by the way, stands for tape archive. Okay, it's not this thick stuff that you thick and sticky stuff. It's actually tape archive. So a tarball is actually intended, to back up, a computer. But since the command is really useful, putting folders and files into one single file, we also use it extensively to basically create one single file to archive a whole folder. All right. So it will create a folder called test. Okay. Once again, you can use ls to confirm that a new folder called test is in fact created. Then you use cd to change directory, to change to test. So then every command that you run is going to be run from the context of the test subdirectory. And then what you want to do is to run this command here, which is just a little Perl script. The Perl interpreter is installed in the virtual machine already, so it should just run fine without any problems. But I also want you to run it by capturing the output. So this command is a little bit different. The greater than symbol is called a redirection symbol, which means all the output of this program is going to be captured in the file called check.log. Okay, so it will create the file if it does not exist already. If it does exist, it will overwrite the content of the file with whatever the output of check.pl is producing. Is that okay? Okay, moving on. So when this is all done, you have to run this command here. So every semester, I have people having trouble with this one, and that's because they did not listen to me in class, did not write down the notes, did not pay attention, did not try to resolve the problems themselves. Okay, so I'm gonna say exactly what I tell my students every semester. First of all, it is case sensitive. If it's an uppercase C, it is an uppercase C. Do not substitute it with a lowercase c. The quotes are backticks, they're not single quotes. Okay, these are back quotes. And you can locate that on a regular keyboard at the upper left corner, right under the escape key, is the unshifted version of the tilde symbol. Is that okay? Okay, if I have any further issues with this, I am going to take a picture of the keyboard and use a red circle to circle the key that is supposed to enter that particular character. Okay, I'm hoping that I would not have to do that with a class at this level. Now, if it's a CIS C300 class, yes. And this is a tilde symbol, so you will be touching that key several times with this command. This is the first time you touch that key, and this is the second time, and this is the third time. These two are going to be unshifted. This is going to be the shifted version of that key. Are we doing okay so far with that command? Cool. Yes?
What is the CZVF?
Very good question. So I'm going to explain that. It's actually explained in the description as well. So tar is the command to create a tarball. It's tape archive. C stands for create, so because you can use it to extract, test, and a few other things. So C means I want to create a tarball. Okay. Z, it means I want to use compression. C specifies the cisp310 compression algorithm, and there are at least two that I know of that tar knows how to deal with. V is just verbose, so it will show you the files that is compressing as it gets the job done. F means the following is the file name that you're creating. So in this case, the file that I'm creating is tilde/testdone.tar.gz. So that's why we have CZVF. The V is really optional, but I like it so just so that I can see what files are included in the tarball. Is that okay? Yeah. All right. Excellent. So let's explain the tilde symbol here. The tilde symbol simply means home directory. Okay, so no matter where you are in the directory tree, every time you say tilde, it refers to the home directory of that particular user. So I'm creating this file at the top level of the home folder. The rest is really just the file name. I know in Windows, people frown at dot something and then dot something again, having double extension or triple extension. In Linux land, it doesn't even matter. Okay, you can have any extension, any chain of dots, it doesn't really care. This dash uppercase C, once again, uppercase, okay? This dash uppercase C means, where the source, where you get the files to create a tarball, is going to be from the perspective of the following folder, which is a single slash, not a backslash. Okay, a single slash means the root folder, which is a top level folder description, top level folder from the perspective of the file system. And then this part here, which is backtick, pwd backtick. Okay, let me explain that one. Pwd by itself is a command. It shows you pwd stands for print working directory, which is basically where you are at this point in the folder structure. But that's just a command. It just prints the output to the console, doesn't really do anything. So the backtick means, take the output of this command and put it here as if it is a part of this command itself. So you're taking the output of another command and say, put it in place here as if the output of this command is a part of the tar command.
So it's like you're executing a function in the command.
Yeah, basically you're just using the return value of a function as a part of this command. So that's the full explanation of this little tar command. You will be using this quite a lot, especially in the second half of this class. So you might as well get used to it at the beginning. So one thing you can also do is to copy and paste this command if you don't feel like typing it. But to do that, you have to use putty because the console cannot take paste. So if you want to copy and paste, you have to run putty because in putty you can actually right-click and paste something. If you run SSH natively because you have a Linux box or a Mac OS X box, you can just use the usual way of pasting as well. Okay, are there any questions at this point? Yes?
What file was downloaded that you're actually?
The file that you're downloading is up there. There's a hyperlink to it. So don't worry, I will do this once in Linux, because if I do it in Windows, I cannot have it recorded. Okay, so this is a typical output of running this command. Obviously, you're not me, so your username is going to be user. So your command prompt is going to be user@Debian, because I think the default name of the VirtualBox or virtual machine is Debian. So you will see user@Debian, and then ~/test. When you run the command just like this one here, you will see exactly this output. Okay, the first one looks like it's an error. It's not. It really is just a warning. It will tell you it's removing leading / from member name. It's okay. It's not a problem. Okay, and there will be about 3 files. If you have any additional files, it's not a big deal as long as it's not trying to archive the entire file system into that one toggle. Okay, because if you did that, if you did not specify the commands correctly, that's something that might happen. Okay. So what this will do is it will end up creating a file in the home directory of the virtual machine called testdone.tar.gz. So what do you do with this file? You want to turn it in. So when the submission file, the file that you're supposed to submit is exactly that file, which means you have to copy that file from the virtual machine back to the host environment where you run Firefox or whatever browser that you access Moodle with, and then you turn it in at the end of the homework description. There's a link that says, submit a file or enter submission or something like that. I cannot remember the exact wording. You click that, and it will give you an interface to upload a file. So you upload this file, testdone.tar.gz, and make sure that you hit a button saying save submission, and then everything will be done. That's my alarm ringtone. So I feel very awakened now. Or I should say more awakened than before. So are there any questions? I can see 6 people have turned it in already. Yes?
You said it would tell us how to shut down, and it didn't.
It did not. Darn it. Okay. So I forgot to specify that part. So to shut down, you want to change to super user using the command su. I'm going to do it here as well. Okay, so I'll do this whole thing, just so that you guys can see how I get it done. And I might even be able to do it close to what I would do it in Windows. Okay. So the first thing I do is I am just going to the first thing is to download and install the virtual machine, which is here. So I'm just going to download it, save link as. And where you put this one, oops, sorry, go ahead.
And is this the only homework we have for the weekend, or we have other stuff you're assigning as well?
There's one more.
Okay.
Yep. So you want to download it. I lied. You cannot right-click on that one. You have to click it, or open as a new tab. And then you just say, download anyway, because it's too big for Google to scan through it. So you just download it, and if you look at the download process, did I push the button?
You did.
I thought I did. Okay, save file, and I'm just going to save it into my default downloads folder. Okay, so this will take a little bit of time, but you can see it's actually really fast. It is probably about 3 megabytes per second. So if you have a slow internet connection at home, definitely do it here. So do this part first, and while it is doing this, I'll do the second part and download the other file as well. So which is this one here, and just save file again. And this one has a different file name. It's test.tar.gz. So when you one more thing. When you turn in your homework assignment, make sure you turn in the file exactly the way it is described. It's test, all lowercase, uppercase D, O-N-E in lowercase, dot, lowercase tar, dot, lowercase gz. Because if the file name that you turn in, if the name of the file that you turn in deviate in any way from the specification, my script that I use to grade homework assignment won't be able to get it. And as a result, your submission will receive no points. Okay, so you have been warned. You have been warned it has to follow exactly that format.
Is it in there?
Hmm?
Is it in the instructions?
The instructions specify this file name varies very clearly. So it appears here once, and it also appears one more time over here. Okay? All right. So I got both files already downloaded. The next part is a little bit different, in Linux. So let me see if I can do it in a way that is very similar to what you guys have to do. So I have the zip file over here, and I do have, I don't have a utility to decompress it, a GUI tool to do it, so I probably have to do it using a command line. So this is a little bit different from Windows. To me, this is easier. To most people, this is harder. So I just unzip the whole thing. And it might take a little bit of time because this QCOW2 file is a huge file. If you're decompressing like what I'm doing right now onto an SSD, it's not going to take too long. It will take probably about 20 seconds or so to decompress that one single file. If you're using a slow, low-speed USB dongle or USB thumb drive, that can take you half an hour. Okay, so don't be surprised if this seems to be taking forever, because it might actually take a long time. Okay, that was all done. So I go to that folder, which is I just put it inside the downloads folder. So this is the content of the Linux folder. You guys will be using start32 or start64.bat in Windows. If you have a Macintosh or if you have a Linux box, you can actually use start.sh, which is a shell script. Okay, since I do have a Linux box here, I'm just going to use the shell script here and say dot without anything, dot space, and then start.sh, and that starts up the virtual machine. And because I'm using Linux, which actually does make full use of the acceleration, portion of the processor, you can see it starts up in a few seconds. Now, if you're doing this on a Windows machine from a USB thumb drive that is slow to begin with, this might take you 3 or 4 minutes. Okay, so I'm pulling that same trick as most of those as seen on TV products. Here's a dish already done. But when you get the machine, when you buy it, it takes a long time to do the same thing. How come? Okay, so I'm actually minimizing the console of QEMU because I want to show you how to use PuTTY instead of using the console. Okay, I might have PuTTY already installed. I have to check because I have to do. Oh, I do have PuTTY. Excellent. So here's PuTTY. And when you start PuTTY in Windows, it's exactly the same thing. Okay, give you exactly the same boxes to enter stuff and whatnot. Remember, when they ask you for the host name or IP address, it's localhost, LOCALHOST. Oops, there we go. So localhost, or if you prefer the numbers, it's 127.0.0.1. Okay, it's exactly the same thing. The port number cannot be 22, it is 2200, 222200. So once you have all this stuff done, you click open, and it will always give you this the first time, okay? It will always ask, okay, are you sure this is the machine that you want to connect to? Just in case of man-in-the-middle attack, that sort of thing. Since this is a virtual machine running on your own box, there's no way there's a man-in-the-middle attack. So you just say accept. It will only ask you once, it will remember that. And it will do a login here. Okay, I can change the font size a little bit later just so that you can see a little better what is going on. So I can log in as user, and the password is user as well. Anytime you want to change the font size, just right click on the title bar. Okay, not in Linux, I guess. Let me see. Nope, that won't change the font size. Okay, I have to do it like before I get in, so I'm gonna close the session. Huh?
You can't right-click in that properties inside the console itself.
No, 'cause
No,
that would
maybe
copy-
here.
That would paste it.
It was in the PuTTY pre-shell window.
Yeah, but once I get in, I cannot change it anymore. Okay, fine, we'll just close it and do it one more time. And this time I will specify a different font. In Windows, you can actually right-click on the title bar and give you the options to change all this stuff. So, this time I'm gonna do it over here, specify the same thing, 2200. And if you are feeling sick and tired of having to do this every single time, you can actually save your session. So next time, if you restart the same session, it will use the same settings, which is kind of cool. So I go to Appearance under Window and go to Fonts, then down here, and change my font to use. I think there's a free. Yeah, mono space may be good for this sort of thing. If I have a terminal, that would be really good for this too. So terminal is good. Except I don't have the font installed, or something is not right. Okay, fine. We'll just use a mono space.
Yeah.
That works. That's not bad.
We can use it.
Okay, so click OK. Okay, now that I have everything already selected, I can actually save my session. So I'm gonna call this VM. Click Save. Then I open. So this way, next time I do the same thing, I can just pick that session, and I would basically pick up the same font, pick up the same local host as IP address, and 2200 as the port number and stuff like that. So I log in as user. Okay, user, all done. All right. So are there any questions about this part here? Yep.
So I downloaded the test file, but I can't find it. Exactly.
You cannot find what?
The test file I downloaded. I'm not sure exactly where my directory is.
Well, when you download, you have to tell your browser where it's downloading stuff. So typically, it's going to be in your downloads
I
folder.
can find the test file. I guess when I log into Linux, I have my prompt like this. I'm not sure exactly what my home path is.
When you first log in, you are at the top of your home directory.
So whatever directory I have, whatever folder I have, the Linux thing, right?
Right, but it depends on how you upload it. Okay, so I'm going to do the second step, which is uploading test.tar.gz into the host, into the virtual machine. Okay, so for those of you who have a Mac, you can do it pretty quickly. Okay, so what you do is you locate that file, which is downloads. Oh, this is the virtual machine, no wonder. Okay, so you have it in your downloads folder, or wherever you put all your downloads files are. So I can see test.tar.gz here. So now I have to transfer this file into the virtual machine. And Winscp as a single command can do this, okay? So you basically specify what file are you copying from, and then you specify where you're copying to. But tag, it's not copying to something on the same machine. It's going to be copying to something else. It can do that actually. So what you do is you specify the username at wherever the machine is. In this case, it's localhost, okay? And then you specify a colon to separate the username and the host from the path where you're going to copy it to. So in this case, I'm going to copy it to the home folder of this particular user. That's how you do it. You press the Enter key. Oh, okay, I forgot one thing. The port number is 2200 because the default is 22, so that's why it doesn't like it. So I think with SCP is an uppercase P to specify the port number. So you basically use SCP uppercase dash uppercase P 2200, and then what you're copying from and where you're copying to with a single line. And it will check the fingerprint, say yes, and then enter the name of the password of the user of the end user, which is user USER itself. Press the Enter key. It's done. Okay. So one single line is getting the job done. Okay. Now, what if you don't like Winscp because it looks really clunky and you don't want to use the command line thing because you're using Windows? FileZilla, exactly. So FileZilla can get the same thing done. You just have to find a way to specify localhost and the port number. The port number is the important part because in some cases, it might be kind of hidden. So you have to kind of drill down the menus to find out where to specify the port number. Yes.
So in Windows, you can use Winscp, and it just like pulls up the box and everything.
Yeah. Winscp has pretty much the same boxes as PuTTY because Winscp is based on PuTTY. So it's going to give you about the same screen, except it doesn't give you the ability to change the fonts because it's not a terminal emulator. It's a utility for copying files. So you will still be entering localhost and 2200. I think Winscp also gives you the option to enter the name of the user on that screen. So you can enter the name and the password of the user on that screen. If you don't, it's okay. It will ask you later on. So it's not any more difficult to use than PuTTY. And then once you get into Winscp, it will give you a left-hand side and a right-hand side. The left-hand side reflects the files on your local system, which is your host in this case. And then the right-hand side is the remote system. You just drag and drop to copy files. Is that okay? Okay. All right, so now that I have transferred the file, I go back to PuTTY and I do an ls here. And sure enough, I have test.tar.gz already copied in the virtual machine. Okay, so next thing I want to do is to unzip or to decompress this file using tar space czvf and oops, no, this is for creating, xzvf for extracting, and just type the file name. No, I did not actually type the file name that quickly. I just typed the T and then used the tab key to autocomplete. Okay, so the tab key is really useful. If you only have one file that starts with a T, the autocomplete will actually complete the file path entirely. If you have multiple files with that starts with a lowercase t, a single tab won't do a single thing, but if you tab again, it will list all the files that starts with a T. Then you can type additional characters to try to resolve which one you want. Okay, it's a really cool tool because it can save you a lot of typing. Okay, so right here I have the command to decompress, and this is the output. Okay, it has decompressed into a folder called test, and it is creating a file called check.pl inside the folder test. So the next thing we do is to cd, change directory, because right now my working directory is the home folder. Okay, this part shows me it's the home folder. This is my working directory. So if I want the working directory to be test, I just say cd, which changed the working directory. I do ls again. This time we have a check.pl file in this folder, and you can see it's in green. Anything in green is quote unquote executable. You can actually run it. Okay. So the next thing we do is to follow the instruction of my homework assignment and run it without the redirection. Press the enter key. It shows you a whole bunch of gibberish stuff, which is not really important. Okay. But this is the output. So the second thing we do is to redirect the output to exactly the file name that I'm asking for. So once again, you don't want to redirect to uppercase C check.log or check.text or anything like that. It has to be exactly lowercase check.log. Okay, so when it comes to file names and stuff like that in this class, it has to be exact. Okay, so I'm going to do the same thing over here, check.log. And it's not going to produce any actual output this time because the output is already sent to a file. So the console is not going to show anything when you run this command. Is that okay? All right. On the other hand, if you do an ls at this point, you will see that, hey, we got a new file. It is check.log. If you want to check the date or when the file is created, you can do an ls-l, which specifies the long format. So you can see that I'm just going to focus on this part here. So check.pl was created a long time ago, okay, more than a year ago. But check.log is created at 9:41 exactly, which matches the time that I ran the command. Is that okay? Okay, so now that I know everything is here, I'm going to create the file that I'm going to use to submit to Moodle. So I say tar, this time czvf, and when you run this command tar czvf and blah blah blah, you have to make sure that you are in fact in the working directory test, because otherwise it won't get the right files into the archive. So make sure you run the tar command when you're in test, the subfolder. So the rest is really just the rest of the command that I specified. So just like that. And as I said a little bit earlier, for those of you who use PuTTY, you don't feel like typing all of this stuff here, I cannot blame you guys for not wanting to type all this stuff, because I have done the same thing when I have to look up some commands to do certain things. So you just, oh, where's the middle click? Nope.
Isn't it just right click?
There is no right click on.
There's no right click on that in Linux.
What about Control Shift V? Control Shift V maybe?
Control
Shift V.
Control Shift V. Nope, that doesn't work either. That's okay, I can just type it.
Well, if we have Linux, we have to type it.
-c/backtick pwd backtick. There we go. Now you also have to remember there are spaces here too. So there's a space between the tar and czvf. There's a space between the f and the tilde. There's a space between the z and the dash. A space between the uppercase C and the slash, and a space between the slash and the backtick. All right. Well, I just spelled everything out. Press the Enter key. Okay, exactly the same output as what I projected a little bit earlier. So the work in the virtual machine is done at this point. So I switch back to the host. Now, once again, since I don't have a GUI tool to transfer files, I'm going to use what again to transfer the files? SCP, which stands for Secure Copy. Very good. Or SSH copy, or whatever, however you want to call that. Okay, so I'll just use SCP, but this time it's reverse. The file that I want to copy from is on the remote side. So do the same thing here, override the port number, and then we specify user at localhost, which is the username and the machine that hosts the file that I want to copy from. And it's going to be in the home directory, and the file name is test.done.tar.gz. And I want to copy it over here into the downloads folder, or if I want to, I'll just copy into the downloads folder. So it's just a single dot, which means the current folder. Press the Enter key, ask me for the password, press the Enter key again, and I'm done with copying the file from the virtual machine back into the host machine. Are we good so far?
Yeah.
Okay. So the details, you can watch it again, okay? That's why I'm screen recording everything, and most of the instruction, if not all, is actually in the notes as well, in the description of the homework assignment. So focus on the concept, okay? Do you know what is a virtual machine? What is a host versus the guest operating system? Which file is remote? Which file is local? And so on and so forth. So focus on the concept, not the details. Okay, so now that I have this done, well, I'm not a student, so it's not going to show me the interface to do that. So let me see if I can pretend to be a student. There has to be a way to do it. Let's see. Nope, that's not it. Okay, well, if I can't do it here, I'm going to sign into Moodle as a student. Oh, then I have to go through the syllabus thing again. Okay, I'm just going to count on you guys knowing what to do, okay? If you scroll all the way down to the bottom of the this homework assignment screen, there is a button that says, turn in assignment, submit a file, or enter submission, or something like that, okay? It's obvious. Sure. It's really obvious. So you go to that button, click that button, and it will give you a download interface. Yep.
Can submission be overwritten?
Yes. So if you turn in a file and that's not what you want to turn in, what you do is you go back and you say.
You
have to say edit. Okay, you have to say edit submission. Okay, so there will be a button, but it's not going to be enter submission. It's going to be edit submission. So you click edit submission, which will show you the file that you have previously uploaded. Then what you do is you click on that file and then you delete it. And then you can upload another file to replace that file. Now, one thing you want to keep in mind is Moodle only keeps track of the last file that you upload. It has no history of the files that you have already uploaded and overwritten. So if a file is overwritten in Moodle, there's no way for me to retrieve it. I can see from the log that you uploaded a file, but I have no idea of the content of the file once you overwrite it.
It's like Dropbox.
Yeah, just like Dropbox and everything else. Yeah. All right. So are there any questions? I know the last part is a little bit vague, but I think if you're in this class, you can manage. Yep.
Will your grading script take off points if we do it on a native Linux installation?
No, it won't.
Okay.
Yep. As long as your submission meets all the requirements that is described in the homework assignment, it will be fine. And I think the homework assignment, yeah, so if you don't want to use a virtual machine, in this homework assignment, that's fine. Should not be a problem.
Okay.
Because there's nothing specific to 32-bit or 64-bit in this homework assignment.
Okay.
All right. Any questions? Okay, so if you, sorry, go ahead.
I'll ask after.
Oh, okay, ask later? Okay. Well, that's what the lab time is for, so when you're doing it on your own machine, and you encounter some point where, okay, I'm not really quite sure what to do now, that's what the lab time is for, okay? I can answer those questions. All right, so I'm gonna do some other demonstrations in the lab for the second part of the homework assignment, or another homework assignment. You have 1 week to do this. Which basically means you want to get started as early as possible so that if you cannot get this done, okay, for whatever reason, on Monday you can bring those questions with you because it's due on Wednesday. You have 1 week to work on this. Yep.
You mean Thursday?
Oh, Thursday, yes. I'm still in the mindset of Monday, Wednesday. So next Thursday is the due date. All right. Any questions? It sounds like a lot of stuff. Okay, well, it is a lot of stuff.
It's all written there though, so if you follow the instructions, you should
Yes,
be good.
the instructions should be fairly complete.
If you've gone this far,
Yeah.
you should be able to.
Yeah.
Well, 6 people turned in something already. I have not graded yet. Okay, so what I want to do now, because this is lecture time, I've already used up a lot of lecture time to talk about really kind of lab stuff. So what I want to do is to continue with the low-level mechanism. And last time we left off with this picture. And what we want to do today is to say, okay, if we look at this picture, exactly what is it doing? Okay, so here's the picture. It has 4 transistors. The top transistors, Q1 and Q2, are what we call P-channel Mosfets. They behave in an interesting way by, if the input is low, they turn on, okay? So when you turn on the valve, it means, the output is connected to the input. Is that okay? So if T1 is a high voltage, then Q1 is going to be turned on, and we can just say that, okay, the circuit is complete. We have a connection from VCC to this line here, which is T3. Yep.
You said if T1 is high, that's the case?
When T1 is high, correct. If T1 is low, then the transistor is off. Okay, I take it back, sorry, I take it back. When T1 is low, the transistor is on and the connection, and there's connection. When T1 is high, then there's no connection, the circuit is open. Yes.
That sounds backwards.
No, it is backward because this is what we call a P-channel MOSFET, and that's how it behaves. Okay, so let's see if I can express this in terms that you already understand from your C and C++ classes. And let me turn on my document camera.
So if it's low, it's open, or if it's high, it's open?
If it's high, it is
It's on.
open. If it's low, it is closed.
No, not a P channel. No, P channel is different.
Yeah,
No.
you said the
If it's
opposite
low,
of
it's
that
on.
first.
I said the opposite by mistake first.
Okay.
But I'm gonna make sure that this is correct. I think the note is correct. So there is that. All right. Have to readjust the orientation every single time. But this beats using the whiteboard in many ways. Okay, so I just need a pen here. Oh, by the way, somebody left a pen on Tuesday. Gave me a pen to sign something and left the pen. So this pen belongs to that person, one person in this class. Okay, all right. So let me just describe what is a P-channel MOSFET. So a P-channel MOSFET looks like this. Okay, I'm not going to go for the entire full symbol here. Okay, let me just double check. Yep. Okay, so a P-channel MOSFET looks like this. So the input can either be high or low. Okay, and I'm just going to call this is what we call the drain. Now this is the drain and this is the source with the P channel. Yep, that's correct. Okay. So a high means the circuit is open, which also means no connection between the source and the drain. Is that okay? And a low means it's closed. The circuit is closed, which means connection between the source and the drain. Is that okay? So it's counterintuitive because a lot of times we say, oh, when you turn on something, if you use a high signal to turn on something. With the P-channel MOSFET, it's exactly the opposite. Okay. All right. So with the other one, which is complementary to this one, is called a N-channel MOSFET, which looks kind of the same thing. The only difference is how you show the gate. Okay. This part here is called the gate, which is actually the control signal that basically specifies should this valve open or should it close. So the only difference is the orientation, whether the bar is on top or whether the bar is below the gate symbol itself. Now, for those of you who are electrical engineers, when you get to a electrical engineering device physics class, they will definitely frown on the symbols that I use today because it's way simplified and the way I explain things is also way simplified. But for software people, this is pretty much as far as you can, as much as you need to know about these transistors. Okay, so with an N-channel MOSFET, so this is a P-channel, this is an N-channel. And once again, the input can be high or low. And then the source and the drain are opposite. In other words, the source is the one that's going down, and then the drain is the one that's going up. But that part does not even matter to you, okay? So all you need to know is, okay, when is the transistor closing the circuit, and when is it opening the circuit? And it's exactly the opposite. A high, okay, this is the gate here. So if the gate is a high, which is this portion here, this is gate. So if the gate has a high signal, it's going to close the circuit. So we do have connection, S and D are connected. And if you have a low at gate, then the circuit is open, which means S and D are not connected. Not connected. There we go. Is this explanation okay? Okay, it's just in terms of, okay, if the input is high, we close the circuit or open the circuit. And it's opposite, okay? A P-channel MOSFET behaves exactly the opposite compared to an N-channel MOSFET. Is anyone taking any electronic classes from ET? Nobody? Usually I have about 1 or 2 people taking classes over there in the same semester. So if they talk about BJTs, which stands for bipolar junction transistors, it's the same thing because a P-channel MOSFET behaves the same way as a PNP transistor, and then an N-channel MOSFET behaves the same way as an NPN transistor. With the difference being there's no actual control current in the case of the field effect transistor, but with the BJT you have a control current that's going between the well, I cannot remember the symbols, but it goes between the what is equivalent to the gate and the source. Yep. And those terms came from vacuum tubes, actually. All right. So with this out of the way, we can get back to our notes. Okay. So we go back to this diagram. And we'll try to figure out what's going on when we turn on T1 and T2. Yep.
So Q1 and Q2 are P channel Mosfets,
yep.
And Q3 and Q4 are the N channel.
That's correct.
Right? Okay.
That is absolutely right. Q1 and Q2 are P channel MOSFETs. They're also called high side transistors. And then Q3 and Q4 are N channel MOSFETs. They're also called the low side transistors. Yep.
And so, when you go back to your hand drawing, you have the P channel. Basically, you have like.
Yeah, I simplified that a little bit.
So you have like basically whatever the gate is like an L.
Right.
How now when we go back to the diagram that we have, how do we see that?
Same thing.
The Q1.
This is the gate.
The arrow direction helps picture.
This is the gate right here.
Arrow out means P, arrow in means
Yeah, well, the easy way that I was taught to remember, which one is N and which one is P, is you P out.
Okay.
Professor, the Q1, Q2, is it high because, why is it high? Like, is it because of top or what's?
Because these transistors are controlled by the voltage differential between VCC and the input voltage. So they have to be on the high side so that they can always be switched. All right, so now what we're going to do is I'm going to overlay things a little bit differently. So I'm going to change the size of this window so it's on one side, and I'm going to display the other window on the other side. Okay, that was good to begin with. Just have to resize it. Well, I can just kind of do this. And then we can put this on the side like that. Flip to the next page. So this way we can run through the 4 scenarios, right? Because T1 and T2 are the inputs, and they can either be high or low. So we have a total combination of 4 possible configurations for the inputs. Okay. So we're going to take a look at those 4 scenarios. I'm just going to line up here so I know where to begin. There we go. So we have T1, T2 as our inputs. In a truth table, T1 and T2 would be the independent variables, because those are the ones that determines other things. They're the input into the whole system. But instead of using true, false, and stuff like that, we just say high or low in terms of voltage. So T1 can be low, T2 can be low at the same time. When T1 is low, T2 can be high. When T1 is high, T2 can be low, and of course they can all be high at the same time. So these 4 is enumerating all the possible configurations for the input. Okay. Now, since we're dealing with a digital computer that is binary in nature, things can only be in one state or the other. So I'm not going to say, well, what if the voltage is in between? Okay, that's not something for us to determine. Okay, for us to worry about. Okay. So instead of just giving you a column for T3, I'm going to give you, a whole lot of columns. In other words, I want to show you the states of Q1, Q2, Q3, and Q4. In other words, okay, which transistors are on and which ones are off, okay? All right, so let's deal with the first row first. The first row has T1 and T2 being low. So what do you think are the states of Q1 and Q2?
On, off.
They're both on, okay? So we'll just say, closed. I'll just use the word C for closed. So T1 and T2 are both closed. What about Q3 and Q4? They'll be off, which means they're open, right? So I'll use the symbol O for open. And by the way, using C for closed and O for open is a typical terminology for relays. because they have a normally open, terminal or normally closed terminal and stuff like that, NC, NO and stuff like that. So this is actually fairly typically used terminology. All right, so given that those are the states of the transistors, can someone tell me what T3 is going to experience? How is it connected? Is it connected to ground, which is low, or connected to VCC, which is high? Yes?
Because there's no linkage between VCC and the ground since Q3 is closed and since Q4 is closed, all of the
No, wait. Q3 and Q4 are open.
Are open, sorry.
So they're not connected.
Open, so not connected. Sorry.
But both Q1 and Q2 are connecting. So T3 is tied to which one? It's tied to, it's going through Q1 and Q2 to which terminal? VCC. And VCC is high or low? That's high. So that means the output is high. Very good. Okay, so this is how we work out, the actual output when we know the input configuration of the transistors. Okay. Second row. Okay. So second row has T1 being low. When T1 is low, Q1 is on, which means it's closed, but Q2 is going to be open, and then Q3 is going to be open, and then Q4 is going to be closed. Very good. Okay, so in this configuration, what is going to happen? For those of you who have taken at least one class in electricity, yep.
T3 is going to be high because Q1 is low.
Yep, Q1 is closed, Q2 is open, but these two are parallel. In other words, when you look at T3, it connects to Q2, but it also connects, the other way, it also connects to Q1. So we have two possible ways to connect to VCC. If one path is closed, it is connected. So that means T3 is connected to VCC. Okay, but let's check the low side to make sure it's not connecting to ground, because that would be a bad thing, okay? So we have Q3 being open, so this transistor is open. Now Q3 and Q4 are connected in series. If one is open, the whole circuit is open. So that means I don't even care what Q4 is, because if Q3 is open, it's not connecting to ground.
So it's gonna, if Q3 is not closed, it's gonna stop there because it can't travel.
Exactly. Yeah, because it's kind of like an AND gate. You need all the switches to be closed in the series in order for the whole thing to connect. So that's why if Q3 itself is open, I don't even bother to look at Q4. Okay. So the output is going to be what? Output is going to be high. What about this case? We have a high for T1 and a low for T2. Well, exactly the opposite, right? We just flip everything. So in this case, Q1 is open, Q2 is closed, Q3 is closed, Q4 is open, which is the symmetric scenario compared to the previous one. Yes?
Professor, Q3 is open, and why is Q4 closed?
Because Q4 is connected to T2, and on the second row, T2 is a high, so it is closed. Okay. Is that okay? All right. Okay, so we have OCCO in this case, which means T3 this time is going through Q2 to connect to VCC. So it is connected to VCC. But on the other side, this time Q3 is closed. We have some hope. But no, Q4 is open. And again, if you have a series of switches, if at least one is open, the whole thing is open. So that's why we have no connection to ground. So T3 is only connected to VCC. As a result, it is a high voltage. Okay. So we have an H here. So the last one, quite obviously, has to be different, because otherwise, this circuit serves no purpose, right? So the last one has T1 and T2 both being high. Okay. So let's check out what's going to happen when both inputs are high. When T1 is high, then Q1 is open. When T2 is high, Q2 is open. So we have O for Q1 and Q2. But on the other hand, Q3 is closed and Q4 is closed as well, because with N-channel MOSFETs, a high gate voltage will close the circuit. So now we have C and C here, which means both Q1 and Q2 are open. There's no way T3 can connect to VCC anymore. On the other hand, Q3 and Q4 are both closed, so there is a path for T3 to connect to ground. This is the only case where T3 is a low voltage. Yep.
Can you explain again how to tell the difference between the N channel and P channel?
Okay, in the non-abbreviated picture, P out. So when you see an arrow going out of the gate,
So
it's a
that's-
P channel.
So that's the P channel.
Right. But in the simplified version, which is something that I displayed earlier, I just use the location of the gate wire to indicate whether it's a P channel or a N channel MOSFET. Your electrical engineering professor will frown at my abbreviated notation, but yeah.
Good thing you're not him.
No, yeah, well, I'm a software guy.
Yeah.
Okay, so now with this truth table, the next thing we want to do is to simplify this truth table, and then we change low to 0. It's an interpretation, okay? Because a low voltage is a physical quantity. It doesn't really mean 0. It's just that we assign an interpretation and say, oh, let's look at low voltage as if it means 0 or false, okay? So now we have T1, T2. This is just a simplification of what we have on the other slide, except we also use 0 to represent low and a 1 to represent high. Okay, I'm just copying everything here. And then we have 1, 1, 1, 0 here. These two are inputs, and this is the only output. So do we have any logical operator that has basically the same properties? It comes close to one of the operators that we know, but it doesn't seem exactly the same as what it is. It's opposite. Very good.
And not T1 and not T2.
Oh, it's the OR operator.
It would seem like it was
No, it's not.
Well, let's find out, because
false.
you guys are noticing a pattern, right? Because you're
It wouldn't be OR
noticing a
because
pattern
one
where
would be
when
control.
both inputs are ones, the output is 0, which is opposite to an AND gate, right? For the AND gate, when both inputs are ones, the output is 1. For everything else is a
This
0.
is a
So it's
not
not and.
It's a not AND, which is simplified to
An
NAND, N-A-N-D gate, okay? So this is a NAND gate, okay? N-A-N-D, NAND gate, okay? So what is NAND again? So let me just kind of give it to you as a C notation, okay? So if I say X NAND Y, it really is the same thing as not X and Y. That's using C notation. And I trust that everybody knows C notation in this class, because 360 is a prerequisite to this class. So are we doing okay so far with this picture here? Okay, let's take a step back, okay? When I teach a class, I encourage people to ask 3 kinds of questions. The first kind of question is how? Low-level detail, stuff like that. How does a transistor work, okay? That's a how. The next thing is what? What are we talking about here? We are talking about a circuit and its behavior. That's the what. Then the next question, which I think is the most important question, but a lot of people do not ask the question, is why? Why do we have to know this stuff? What is the significance of this stuff here?
That's how you write assembly language?
Well, we'll get to that part. We're a little bit far away, but it is related, okay? Eventually it will get to the assembly language part, okay? But at this point, okay, let's take a look at this one here. Not, in parentheses, X and Y. What is that to you?
That's a
That's
Boolean.
Boolean. Okay, I like the word Boolean. Logical operators, right? Boolean operators, logical operators.
Basically, it means if something and something is true together, then it's not true.
Right, something they can do in a program, in logic. Yes? What about this stuff on the left-hand side? What is this picture representing? Physical stuff, okay, components, transistors, things that we can actually manufacture and put onto a computer. So what I have done at this point is to make a connection between things that I can make as electronic components to things that we want to do in the programming language inside the computer. That's the bridge, okay? That is the significance of this screen right now, okay? The significance is I am connecting physical components, okay, arranged in a particular way to a very simple, I know this is really simple, but a very simple operation that you can perform in logic, okay? Now, is this a really cool operation? No, not really, okay? It's just an and it's negated, okay? But from this, we can make just about everything else. Okay, so let's go ahead and continue to read the slide a little bit and see what kind of stuff we can make out of this kind of really awkward kind of gate. What is a NAND gate? I mean, okay, this is a NAND 2 gate. Everything that I just talked about is kind of captured here, but the NAND gate is indeed mighty. Mighty, not mightily, by the way.
Does the 2 just signify there's 2?
The 2 signifies there are 2 inputs, because you can easily extend it to have n inputs, but we just want to stay with 2 inputs. Okay, so the first thing we want to do is, okay, it's a NAND gate, but can we turn this into a NOT? In other words, can we implement a simple negation using a NAND gate? And the answer is, easy peasy. All you have to do is to tie the single input to a negation to both of the inputs of the NAND gate, then it becomes negation. Right? Okay? Well, you can double check with the truth tables kind of thing, but pretty sure this works out. The second thing we want to do is, okay, but what about disjunction? Because we like OR gates, right? Because we don't typically deal with NAND gates. I mean, that's just awkward. So with the OR gate, we first use an equation to figure out, can we express OR using negation of an AND? And the answer is, yes, we can. Okay, so this is in mathematical symbol. A or B is the same thing as the negation of A or B. Does anyone have a problem with that?
That's a mouthful.
Well, it's a mouthful, it's double negation, but nonetheless, it does not change the meaning.
Right.
It simply means it ain't no A or B, which means A or B. Okay, so now this one here, the second step is a little bit tricky because I am applying what we call De Morgan's law. Okay, we'll get to De Morgan's law later on. You don't really have to understand it at this point, but by using De Morgan's law, I can now transform something that uses a OR into something that uses an AND by distributing the negation from the outside to the inside. So by distributing the negation from the outside to the inside and changing the OR to an AND, I preserve the actual meaning of the expression. But that didn't take care of the outer negation, which I will just leave alone because we know how to do negation already. So by using this, I can now say, oh, this little circuit here, which only makes use of NAND 2 gates, will function as an OR gate. Okay, because this is one input, this is another input, A, B, right? This is just doing negation using a NAND 2 gate. So this is not A, this is not B. This is not A and not B, which is basically what we have here. Yep.
So why aren't we just making OR gates?
Because we already know how to make a NAND 2 gate.
So
I'm just showing you the possibility. Okay, I'm pretty sure there's an easier way to make an OR gate, but by just knowing physically how to configure transistors to make a NAND 2 gate, I can already make a NOT, I can make an OR, and I can also make a regular AND gate. Now, regular AND gate is easy because it's just a NAND followed by a negation. So this negation here is just negating the negation of the NAND, so we just basically ends up with a regular AND. But the bottom line is, by using 4 transistors to make a NAND 2 gate, and by combining the NAND 2 gates, we now have NOT, AND, and OR. No one seems to be fascinated. Okay, I am fascinated.
You could also say that like most SSDs are made with strictly NAND gates.
Correct. That's one way to look at it. Okay, so I think this is huge. Okay, I think this is huge because with just 4 transistors, or a special way of connecting 4 transistors, now we get to the logical stuff. We can do everything that we already know about logic, negation and OR. Okay, that is big. Okay, but tag, how do we add numbers? Show me how to add numbers using NAND 2 gates. You know what? We will do that later on. Don't worry, you will have homework assignments to do that. So we are going to build, the circuitry inside the processor step by step, starting with transistors and NAND 2 gates. And then from NAND 2 gates, we get to NOT, AND, OR. And then from that, we get to adders. And then from that, we get to latches, flip-flops, and so on and so forth. And then before we know it, halfway through the semester, we have a processor, magically.
Dang. That's a little mind-blowing right there.
But that's the history of electrical or computer engineering. That's exactly, the whole chain of technology and science and engineering that makes computers possible.
So they just build on top of each other then? Exactly.
Now, there are some designs that I look at and go like, wow, that is smart. Because I could not figure out that by myself. It's like, I look at it, I understand it, but I cannot possibly come up with designs like that. Okay, so we'll get to those things, especially with the flip-flops. Those are really tricky and smart designs. Okay, so we have 1 minute left. One more thing. So I'm going to skip to this picture here. Okay. So this is about representation versus the meaning of the representation. Okay. So if I were to ask you, how many samurais do we see here?
7.
There are 7. Okay. Can someone use some other native tongue to represent the quantity of 7? Spanish. What is 7 in Spanish? Okay. In Russian.
Sam.
In Indian. Okay. In Chinese. Okay. In Cantonese is chat. Okay. In Japanese. Okay. All right. So all of those are quote unquote representations of a particular quantity. Is that okay? So in computer science, we basically look at values as one thing. The value is 7, okay? This is 7. But the representation of 7 depends on what language you're talking about. So in computer science, we can use base 2 to represent the quantity of 7. I can use base 8 to represent the quantity of 7. I can use some really oddball base if I want to. I can use base 5 if I want to. That's perfectly okay. Okay? So the bottom line is, don't let the value that you're representing, that you're trying to represent, confuse with the actual mechanism to represent it. Okay? Because from here on, we'll be seeing a lot of zeros and ones. So the question is, what is this 0 representing? Well, unless there's a mechanism to interpret that 0, don't even bother with the interpretation. Okay? A 0 is just a 0. Okay? So take a very Zen approach to looking at zeros and ones. It is what it is. Okay? Don't try to interpret. Don't judge. Just let it be. Okay, so that's my advice for the rest of this week. I'll see you guys next Tuesday. Well, no, I'll see you at the lab. Correct.
Early time to go home.